Given f of x is equal to negative x squared plus 2x plus 3, let's write the function in vertex form. The first step is to make the coefficient of x squared is equal to 1. We get negative x squared minus 2x plus 3. Because we want to complete the square, we need to add and subtract 1 over 2 times b over a squared. From the original function f of x, a is equal to negative 1, b is equal to 2, and c is equal to 3. So b over a is 2 over negative 1, which is negative 2. We have 1/2 times negative 2 squared, which is 1. This negative 2 came from negative 2x. Then we get negative x squared minus 2x plus 1 minus 1 plus 3. The next step is to remove negative 1 from within parentheses. We get negative x squared minus 2x plus 1 minus 1 times negative 1 plus 3. It's equal to negative x squared minus 2x plus 1 plus 1 plus 3. We get negative x squared minus 2x plus 1 plus 4. We get negative x minus 1 squared plus 4. Let's determine if the parabola opens upward or downward. It opens upward if a is greater than 0. It opens downward if a is less than 0. So from the original function, a is equal to negative 1. From vertex form, a is also equal to negative 1. Because a is less than 0, the parabola opens downward. Let's identify the vertex. The vertex is the point at h, k. From the quadratic function in vertex form, h is equal to 1 and k is equal to 4. So the vertex is 1 and 4. Let's determine the axis of symmetry. The axis of symmetry is a vertical line. X is equal to h. Because h is equal to 1, the axis of symmetry is x is equal to 1. Let's find the x-intercepts. At the x-intercepts, y values are equal to 0. So we want to solve f of x is equal to 0. We have negative x minus 1 squared plus 4. By subtracting 4 from both sides, we get negative x minus 1 squared is equal to negative 4. By dividing both sides by negative 1, we get x minus 1 squared is equal to 4. By taking square roots on both sides, we have x minus 1 is equal to plus minus square root of 4, which is plus minus 2. By adding 1 on both sides, we get x is equal to 1 plus minus 2. So x is equal to -1 and 3. The x-intercepts are -1, 0, and 3, and 0. Let's find the y-intercept. At the y-intercept, the x value is equal to 0. So we want to solve y is equal to f of 0. We get -0 minus 1 square plus 4, which is -1 plus 4, and it is equal to 3. Let's determine the minimum or maximum value of the function. If the parabola opens upward, then the vertex is the minimum point. If the parabola opens downward, then the vertex is the maximum point. From the part A, we know that the parabola opens downward, so there is the maximum point. The vertex is h, k. Because h is equal to 1 and k is equal to 4, we have 1 and 4. So at x is equal to 1, the maximum value is 4. Let's find the domain and range of the function. The domain of a quadratic function is from -infinity to infinity. If there is the minimum value, then the range is from the closed interval of minimum value to infinity. If there is the maximum value, then the range is from -infinity to maximum value included. From the previous part, we know that there is the maximum value, 4. So the range is from -infinity to 4 included. Let's sketch the function. The parabola is downward. The vertex is 1 and 4. The x-intercepts are -1, 0, and 3, 0. The y-intercept is 0, 3. By connecting all these dots, we get the following graph.